In this video, I will be discussing about integration of powers of sines and cosines. So to do this, we need to recall our trigonometric identities which we've learned from our trigonometry, which gives us the Pythagorean relation that sine squared plus cosine squared is equal to 1. And that if you are going to subtract both sides of the equation by cosine squared, we have this trigonometric identity that sine squared x is equal to 1 minus cosine squared x. And also, if we are going to subtract both sides of the equation by sine squared x, we have this cosine squared x, which is equal to 1 minus sine squared x. Now, we will make use of these trigonometric identities in integrating some powers of sines and cosines. So in this video, I will be discussing two cases of powers of sines and cosines. Case number 1. The integral of nth power of sine u du, or the integral of the nth power of cosine u du, where the exponent n is an odd integer. So to give an example for this case number 1, we have here the integral of the cube of cosine x dx. So here we notice that the exponent is an odd number. So this integral belongs to this case number 1. So the technique is to pull out one factor of cosine x. So we have here the integral of the cosine squared x times the cosine of x dx. So here we have the cosine x that is being factored out from the cosine cube x. Now, if we will let this one as our du, we need to figure out what should be our u. So if our du is in terms of cosine, then therefore our u must be in terms of sine. So we need to express this cosine squared x in terms of sine. So using our trigonometric identity here, we have the integral of 1 minus sine squared x times the cosine x dx. So we just replace the cosine squared x by its trigonometric identity, which is the 1 minus sine squared x. And since this is a binomial, multiplied by our du here, we need to distribute our du to this binomial. So we have here the integral of cosine x dx, because if you are going to multiply cosine x dx to 1, we have this one here. And this will be subtracted by the integral of sine squared x cosine x dx. If we're going to multiply this cosine x to the sine squared x. And you see that this is very easy to integrate here, because if this is our du, we realize that our u must be in terms of sine. So if we're going to write it here as a side solution, that if our u is sine x, we notice that our du here, if you get the derivative of sine x, it is cosine x dx here. So if we're going to substitute this one here, we have the integral of cosine x dx minus the integral of u squared, because our sine x is our u here, this one. And then this cosine x dx is our du. Then therefore, using the formula which we've learned from our previous video, that the integral of cosine x dx is sine x. And then using the power rule, this is minus u cubed over 3 plus c, because you are going to add 1 to the exponent of 2 here, which we have here the cube power, and that is the number that will be divided to u. So going back to the value of u, we have sine x minus our cube of u, and our u is sine, so this is sine cube x over 3 plus the constant c. And this is our answer when we integrate cosine cube x dx. Now let's proceed to our second example. In our second example, we have our exponent to sine x, which is 5. And 5, we know this is an odd integer. So the technique is to factor out 1 sine x from this 5th power of sine x. So we have the integral of sine to the 4th x times the sine x dx. And the goal is to make the sine x dx as our du. So if sine x dx is our du, we realize that our u must be in terms of cosine, because the derivative of cosine is sine. So our next step is to convert this one in terms of cosine. So we know that the sine to the 4th x can be expressed as a second power of sine squared x. And then this will be multiplied by our du, which is sine x dx. And what's the purpose of expressing the sine to the 4th x in terms of sine squared x? The purpose is to express the sine squared x in terms of cosine squared x by using this identity here. So we have the integral of 1 minus cosine squared x, but this will be raised to the exponent of 2 because we have here an exponent of 2. And then we need to square this binomial here, and we know from our algebra that the square of a binomial is the square of the first term, and the second term is obtained by the twice of the product of the first and the second, which is 2 cosine squared x, and then we square the second term, which is cosine to the 4th x, and this will be multiplied by sine x dx. Now we notice that this is a trinomial, so the idea is to distribute this sine x dx to each of the term of this trinomial, and then apply the integral of a sum and difference of terms. So we have the integral of sine x dx because 1 times sine x dx is this one. And then we have minus the integral of 2 cosine squared x sine x dx here. And then if you distribute this sine x to cosine to the 4th x, that is the integral of cosine to the 4th x sine x dx here. So you notice that each of these 3 integrals, we have the sine x dx as a factor to the powers of cosine x. So if we are going to write it here as a side solution, we have u, which is equal to cosine x. Our du, we know that this is the negative of sine x dx. So by substitution, we have minus 2 of the integral of, instead of writing cosine squared x, you will write u squared, because our cosine x is our u here. And then this sine x dx is the value of our negative du, because if you multiply both sides of the equation by negative 1, this is equal to negative du, which is equal to sine x dx. So instead of writing sine x dx, we will replace this one by its value, which is equal to the negative du. And then we have this integral of u to the fourth, because again our cosine x is our u and our sine x dx is the value of our negative du by substitution. So multiplying this negative to the integrand, we have the integral of sine x dx, and this negative here, when multiplied by the negative, becomes positive. So this is plus 2 of the integral of u squared du. And then this negative, when multiplied to positive, that becomes negative of the integral u to the fourth du. And then applying our trigonometric formula for integration, we have negative cosine of x, because the integral of sine x is negative cosine x. And then by the power rule, we have u to the power of 3 over 3. And this will be subtracted also by this integral, which is u to the power of 5 over 5 plus the constant of c. So going back to the value of our u, which is cosine x, we have negative cosine x plus 2/3 of the cube power of our u, which is cosine. So this is cosine cube x minus 1/5 of our u to the power of 5. And our u is cosine x here. And this will be added to the constant of c. So this is our answer when we are going to integrate the 5th power of sine x here. And for our case number 2, we have the integral of the nth power of u times the nth power of cosine u du, where at least one of the exponent here is an odd integer. So let's have an example for this case here. Our example is the integral of the sine cube x times the cosine 4th x dx. So how do we integrate this one? The idea is to look for the odd exponent, and our odd exponent occurs in the function of sine. So the technique is to pull out one sine x here from this odd exponent of sine x. So we have the sine squared x times cosine 4th x times sine x dx. So we have here our sine x as a factor from the sine cube x. Now, our idea is to make this one as our du. So, common sense will tell you that if our du is sine x, then our u must be in terms of cosine. Because if you write here as a side solution that our u is cosine x, then our du here is the negative sine x dx. So therefore, it is very logical to convert this one in terms of cosine. And we have here a sine squared x to be converted in terms of cosine. So we will use our identity that sine squared x is equal to 1 minus cosine squared x, and this will be multiplied to the cosine fourth x times sine x dx here. So if we are going to distribute this one to this binomial, we have the integral of cosine to the fourth x sine x dx. And this will be subtracted by the integral of cosine to the sixth power x times sine x dx, because if we're going to multiply cosine to the fourth x to cosine squared x, that is cosines to the sixth x, and this will be multiplied to sine x dx. And you can see that our factor here is a sine x dx, but we have here negative sine x dx. So what we will do is to multiply both sides of the equation by negative 1 so that the negative sine x dx becomes positive. So our value of sine x dx is negative du. So by substitution, we have the integral of u to the fourth times negative du, because our cosine x is our u here, and our sine x dx is our negative du. So to continue, we have the integral of u to the power of 6 times negative du. So multiplying our negative here, we have the negative of the integral of u to the fourth du minus of the minus here. So we have plus the integral of u to the sixth times du. And then by the power rule, this is equal to u to the power of 5 over 5, because the integral of u to the fourth du is u to the power of 5 over 5. And this will be added to the integral of u to the sixth du, which is u to the seventh power over 7, plus the constant of integration c. So therefore, minus 1/5 of our u, which is cosine. So 1/5 of cosine to the fifth x plus 1 over 7 cosine to the seventh x plus the constant of integration c. And this is our answer when we integrate our sine cube x cosine to the fourth x dx here. And to give more example for this case, we will have the integral of sine cube x times the cosine cube x dx here. Now you see that our exponents here are all odd, and this integral belongs to case number 2 because there is at least one odd exponent. So the idea is to pull out one factor from the odd exponents. So you may decide to factor out sine x from sine cube x, or a cosine from the cosine cube x here. Now suppose let's factor out from cosine cube x. So we have the integral of the sine cube x times cosine squared x cosine x dx, because our idea is to make this cosine x dx as our du. So if this is our du, our common sense would tell us that our u must be in terms of sine, because if we will write it here as a side solution, if we let u be our sine x, our du here is cosine x dx. So the technique is to convert this one in terms of sine. So we need to convert cosine squared x in terms of sine. So to convert that one in terms of sine, we need to use our Pythagorean identity, which is cosine squared x is equal to 1 minus sine squared x. So this is sine cube x times 1 minus sine squared x, and this will be multiplied to our cosine x dx here. Now, multiplying this one to our binomial, we have sine cube x minus sine to the 5th power x, and this will be multiplied to our cosine x dx. So distributing also this one to this binomial, we have the integral of sine cube x cosine x dx minus the integral of sine to the 5th x times cosine of x dx. So by substitution, because our sine x is our u here, so we write u to the power of 3, and our cosine x dx is our du. So we have du here, minus the integral of u to the power of 5 times our cosine x dx, which is our du. So using the power rule in integration, we have u to the power of 4 over 4 minus u to the power of 6 over 6 plus the constant of integration c. So going back to our value of our u, which is equal to sine x, so this is 1/4 times the sine to the 4th x minus 1/6 to the 6th power of sine x, and this will be added to our constant of integration c. So this is our answer when we integrate our sine cube x times the cosine cube x dx here. And that's it. If you learned something today, please check out my channel for more videos like this and click subscribe. Click the notification bell below so you'll get notified whenever I'll be posting a new video. Don't forget to like this video to show your support. And always remember to math your way up. Thank you.